Okay guys, so quick video. We're going to kind of shift gears from talking about discrete random variables and move on to continuous random variables. So discrete random variables commonly arise from situations that involve counting something. So remember I said in class that we think of they are countable. So it's 1, 2, 3, 4, 5. Continuous random variables are not really going to be countable for us. So situations that involve measuring something often result in a continuous random variable. So it's good to realize that discrete random variables are going to have gaps or interruptions, so 1 all the way to 2. But continuous random variables won't have that gap, so it's everything in between. So a continuous random variable x takes on all values in an interval of numbers. The probability distribution of x is going to be described by a density curve. So the probability of an event is the area under the density curve and above the values of x that make up the event. So we pretty much already know this topic because we've done it pretty much in Unit 1. Not much is really going to be any different other than the idea that we're now discussing continuous random variables. So something to realize is that you cannot assign probabilities to each individual value of y and then just add them, because there are infinitely many possible values for a continuous scale. So there are going to be no gaps or interruptions, and that's why we use the density curve to describe the probability distribution. So quick example, fairly easy, but I think it kind of sums it up. So the random number generator will spread its output uniformly across the entire interval from 0 to 1 as we allow it to generate a long sequence of random numbers. The results of many trials are represented by the density curve of a uniform distribution. The density curve appears in green in the figure below. It has a height of 1 over the intervals from 0 to 1. The area under the density curve is 1. It has to be. And the probability of any event is the area under the density curve and above the event in question. And our event in question is going to be, looking for the probability between 0.3 and 0.7. So, I mean, we could see, well, first off, it says it right there, but we could clearly see that it's going to be 0.4. But let's just remember that we are talking about the area in between, in this interval under the density curve. And so they tell you that the density curve has a height of 1, and we're taking up a width of 0.4 here. So area would be height times width. The height here is 1. We're taking up a width of 0.4 in this interval, and so there's the probability. Okay. So before we move on to a more relevant example, let's just quickly look at some more notes. So the probability model of a discrete random variable x assigns a probability between 0 and 1 to each possible value of x, of course. A continuous random variable y has infinitely many possible values. All continuous probability models assign probability 0 to every individual outcome. Only intervals of values have positive probability. So let's take a look at an example, and it's really nothing new here, guys. It's basically a review of what we already know about normal distribution and density curves. So the heights of young women closely follow the normal distribution with mean of 64 inches and a standard deviation of 2.7 inches. This is a distribution for a large set of data. Now we choose one young woman at random. Call her height y. If we repeat the random choice very many times, the distribution of values of y is the same normal distribution that describes the heights of all young women. Find the probability that the chosen woman is between 68 and 70 inches tall. So what is the probability that a randomly chosen woman has height between 68 and 70 inches. So they tell us y for our variable here. And so ultimately we are looking for that height, that variable, to be between 68 and 70 inches. Okay, so let me just flip to another page so I have more room to do this work. Okay, so just a reminder of what's important here. Our normal distribution has a mean of 64 and a standard deviation of 2.7. We're finding the probability of the heights between 68 and 70 for a randomly chosen young woman. So there's two ways we can do it. Ultimately, we're going to do the fastest way, which is throw everything into our calculator. But let's just remind ourselves that we do need z-scores in order to find the areas between the intervals that we're concerned with. So to find the z-scores, we're going to take our actual value or observed value and subtract it by the mean and divide by our standard deviation. So we have a z-score of 1.48 for the 68 inches, and for the 70 inches over our standard deviation, we're going to have a z-score of 2.22. After finding the z-scores, now I understand I'm looking for the probability of a z-score between 1.48. Actually, that should really be z here. The probability of our z-scores being 1.48, well, between 1.48 and 2.22. So this is where we would use our calculators. So we'd look for, what we would do is we'd need to go to norm CDF, and we'd give ourselves a low boundary like negative 999 to 2.22, and we'd do the same for the z-score of 1.48. And once you put this into the calculator, so this was the lower boundary to the upper boundary, and then it's the same thing here, and so this one would be 0.9868, and this would be 0.9306. You guys can practice putting it into the calculator. I don't have a calculator on the computer, so I'm not able to show you guys. And so now for this, what we're going to have to do is subtract our z-scores from that were less than 2.22 minus the z-scores less than 1.48. And so I have to do the 0.9868 minus the 0.9306. And so my probability, or my area under the density curve between 68 and 70 inches, is 0.562. We'll interpret that in a second, but let's just move to the quickest way to do it, which is to pretty much just throw it all into the calculator. So here's the same thing again, but this time let's talk about how we would throw it into the calculator in one quick shot. So that would be norm CDF, of course, but this time we'll set our lower of 68, our upper of 70 inches, and then, so actually let me just say, in case we forget, the order in which you put it into your calculator would be the lower boundary, your lower z-score, to your upper boundary, and then your mean and standard deviation. And so for this, it would be putting in norm CDF for 68 to 70 with a mean of 64 and a standard deviation of 2.7. And you throw all of that into the calculator, and of course it's got to give you the same thing as when we used our z-scores. Okay, and so now how we would interpret this is that there is a 5.6% chance, because it is probability, so it's a 5.6% chance that a randomly chosen young woman has a height between 68 and 70 inches. 5.6% chance that a randomly chosen woman and 70 inches. Okay. And that's it, guys. So make sure that you finish your, check your understanding that we didn't get to in class, and write any notes that you want to, and I will see you next class, and we will continue with random variables.